Hello and welcome. So we will talk about vectorization and how we can improve the performance of our forward operation, that is the Z operation, and why the vectorization method is used instead of normal Python for loops. Okay. So for vectorization, we will be using a mathematics operation which is known as dot product. So a dot product, let me show you. Suppose we have two vectors, all right. First, let's say we have a vector A and we have a vector B. Okay. So the dot product between the two will be defined as summation of A of I into B of I. Okay. So this is what is dot product means. So if you recall what we were doing in our previous videos, that suppose we had three inputs. Let's say these are x1, x2 and x3, and this was our neuron. Okay. So they so the function, so it has two functions, all right. The neuron, one is to summation of all the weights into the inputs. Okay. So this was the operation and plus a bias. So this was we were doing in the previous videos. Okay. So as you can see, this equation and this equation seem similar, right? So we can substitute and we can use dot product to enhance and improve the efficiency of our neural network, the forward operation. Okay. Z. So for a dot product, the length of the two vectors, A vector and B vector, should be equal in order to perform the dot product operation. And the result of the dot product will always be a scalar value. Okay. Suppose we were doing in the previous examples that 1.5 into 1.3 plus zero point 0.6 into zero point 0.5 is equal to something value. So this was a scalar value. We can perform addition operations between two vectors. Similarly, the dimensions or the length of both vectors should be same. Okay, the length of A vector and length of B vector should be same. For example, if I have A vector to be say 1, 2, 3, 4, sorry, I missed 4. So, and B vector will be 67, 68, 69, 9. Okay, so the length of A is 4, length of B is 4. So both have same length. So yes, the dot product can be applied on vector A and vector B. So how does the dot product gets calculated? So this is the formula. Okay, so we will calculate the dot product between A and B. Okay, so this will be 1 into 1 plus 2. Oh, sorry, not 1 into 1. Okay, I'll just clear the screen. This is the length. As the length satisfies, as the length is equal, okay, so we can apply dot product. So what will be the output of the dot product is 1 into 5 plus 2 into 6 plus 3 into 7 plus 4 into 8. Okay, so 1 into 5 or A dot B, 1 into 5 1 into 5 plus 2 into 6 plus 3 into 7 plus 4 into 8. Okay, so this will be the output, some value. Okay, so this is what dot product is. We use dot product because it is extremely fast when compared to traditional for loops. So now let's code a single neuron like we did in the first video, but now using the dot product and addition of vectors with the NumPy library. The code will become much simpler, shorter, efficient, and faster. Okay, so I'll just comment out this for a minute. Let's suppose we have input 1.2, 2.5, 6.1, so 9.3 or something. And we have weights, let's say 0.4, 0.25, 157 and 0.15. Okay, and we have bias is 1.5. Now the output, and before that let me import the numpy library. So output will be np dot. So this is the function which provides us the dot product, and it is also used for matrix product. Okay, which we will use in the later videos. So it will be inputs and weights. Okay, and now the bias. So now let me run this code and see what the output is. Okay, so the output comes out to be 7.49. Okay, so if we use traditional approach, that is, if we calculate the output like this, inputs of 0 into plus inputs of t into weights of, so 3 plus bias. Okay, and now I will run the program and see the output. So here you can see that both the values are same for both the formulas. Okay, so that means this was the two approaches that we can use, but we will use this np dot dot function in the future videos because this is more efficient and faster. Now let's modify this code uh, to the previous videos, okay, where we had multiple neurons, that is multiple weights values, okay, and one input value. This I'm talking about the this code, okay, that we did in the previous video. So I'll just copy the weights values and the bias values. Just a second. Okay, and here instead of these weights and biases, I'll just copy and paste this. Okay, now cool. Now let's compute this. Okay, let's run this biases. And the input will be same. All right. Okay, so now I will run the program and see what will be the difference, or it will be the same. Okay, at my guess, it will be the same values. Okay, this the output, the value of this output and the value of this output should be the same. Okay, because we used the same computations, but the approach is different. Okay, so now as you can see, both the values is almost same, right? 2.68, 2.68, 3.22, 3.22, and similarly the other two values. So we can see that using this np dot dot product function, we can compute the z value, the output of the neuron value, right? Instead of all this, we just had one line, okay, to help to compute this, and it is much faster also. Now one thing to remember is that always remember to put the weights now on the first argument and input our second argument, because what it does inside, so what is happening inside the dot function is, so okay, instead of just explaining this here, I'll explain it on the whiteboard. Okay, so consider this np dot dot. So this will be our outputs, right? Outputs is equal to it. It will be a list of np dot dot weights of 0 into inputs, comma np dot dot weights of 1 into inputs, comma, and similarly for second item in our weights list, inputs plus the biases. So this is what happens inside the np dot dot operation. Okay, it actually treats the list of lists weights vectors to single list item, and then uh, calculates the dot product between the two, okay, sequentially. So this is what computation happening inside the np dot dot function. So yeah, so this was all for this tutorial, and I hope you liked it. Please do like and subscribe to my channel, and we will meet in the next part.